Hello, Flat Earth researchers, debaters, and debunkers. I hope you're here as someone who wants to make progress and develop our ideas and understanding of the most fundamental and most important questions that we all have and remain unanswered, so that we are at complete liberty to discuss the place we find ourselves in, who we are, what we are, where we are, how we got here, and maybe when we are. These are all questions that remain unanswered by any form of science and possibly many forms of spiritualism or religious belief. So I'm only interested in discussing the things that will help us move forwards. I'm not interested in circular debates or being drawn into one-upmanship or pissing contests or distractions or this dogged determination to stick to a single-minded belief or any kind of religious or cult behavior or direction. The whole thing here is to get back to the basics and understand and realize the difference between knowledge, real knowledge from our own experience, our real tangible experience, and belief, that of belief. So the whole point here is to try to detach and abandon any form of belief or any form of knowledge that has not been gained with a great deal of confirmation from scientific methods. So it's very important to establish first principles for discussing the observations that we make and perspective, regardless of the assumed shape of the Earth. We shouldn't really assume a shape in the first place. My personal take on it is that we are definitely not on a spinning globe going around the sun. This is just one interpretation that has been made of the observations we make looking up into the sky. The whole entire heliocentric globe Earth belief or model has been fabricated from making observations in the sky. There is no measurable proof of the dimensions of the Earth that we are on, or any physics that fits the idea that we can be on a globe that is spinning through space. So that's where we're at. I do not make any claim to any model, and I don't think anyone should be. Of course, we're at liberty to discuss what models might fit, what we can all collectively prove or ascertain for ourselves. But anything beyond that must be admitted to be the unknown. So we cannot hold any attachments or beliefs to these things until we can discover for ourselves the full dimensions of this Earth, which could be extremely large, could be infinite, as much as we have been led to believe the universe is infinite. I'm open to infinite possibilities. It could be possible that we are on an Earth that does move. Who knows? But that, in my mind, is yet to be properly ascertained through any kind of confirmation or scientific proof. So we should be all free to discuss concepts and ideas, but also with some logic and rationale that allows us to discuss and formulate foundations for moving forwards, rather than people attempting to continually topple those foundations. So when we want to establish first principles, when it comes to perspective, it's very important to talk about eye level and understand what that really is compared to the line of sight. What's the vanishing point or the vanishing line, and the horizon. These are very important factors to consider, but also be very clear about what they actually mean, because when it comes to arguing with people who wish to defend the globe, level becomes something arbitrary, and it can change, and the line of sight gets confused with the horizon and eye level. These things should be very, very clear. And anyone who wants to distract from that or confuse the issue is just doing so intentionally to avoid any kind of commitment to establishing a way we can communicate that allows us to move forwards and discuss things in an adult manner rather than the childish rhetoric we often see. And that goes for both sides. I don't want to see people calling each other names and things like that, because people are mirrors. So if you're coming here with inquiries and we can share information and we can acknowledge each other's points of views, but also at the same time be clear about the terminology we're using. If people can't stick to this, then there's no point in being here. So let's just go through what these different things mean. So eye level is this. Essentially, we are looking directly ahead, and so the eye level is in the center of the field of view, and it is level as it is a horizontal line both across from left to right, but also in the center of our field of view. So if we were to look at it from a slightly different perspective like this, let's just got some more words to put up here. Hang on. Yeah. We have a side-on view of the observer. So the eye level is this horizontal line only, a perpendicular line from their vertical, the up and down. And this is a local up and down. It has no relationship to where one might perceive we are, as in having a down that is towards the center of a spherical mass. This is not about that kind of level. We have to avoid getting that mixed up. Eye level is basically someone's local eye level standing on a flat surface, and their line of sight is horizontal or parallel to a flat surface, like this. Okay, so they have the eye level and it's parallel. It's a parallel line. So anyone who is another point of reference or another person that is level with this person here is in a direct line of sight, a horizontal line of sight there that is perpendicular to the vertical. But the other one, the line of sight, this one is just that, a line of sight. It is directional. So the moment we move away and look up or down from this eye level, it just becomes a line of sight. This is no longer eye level. And we have the center of our field of view targeting something specific in the distance. That is our line of sight. And so it only becomes eye level when that line of sight is horizontal or parallel to another line of sight or another surface, a flat surface. Hope that's clear there. So the vanishing point is basically the limit of our vision. Sometimes that is the horizon, but sometimes it's just as far as we can see, depending on all kinds of things like conditions. But it's basically the vanishing point is in the center of our field of view, whichever direction we are looking. It's just as far as we can physically see, and where our perspective comes into a focal point in the center of our field of view. So this, of course, can become a vanishing line if we can see any kind of horizon across a flat surface. And the horizon, as far as I'm concerned, is not a hump or a rise or any kind of assumed curvature. Even if you want to believe that we are on a spherical Earth, it is clear and obvious to anyone who makes an observation or many observations of horizons that this is something that is personal. It is in our eyes. It is an optical phenomenon that occurs across a flat surface. And of course, there is a difference between horizons inside and outside, but we have the horizon in front of us affected by all kinds of conditions. But one thing it clearly is not is any kind of hump of curvature, regardless of the shape of the Earth you think or believe you are on. The horizon is an optical phenomenon that occurs in our eyes when we look across a surface. Now, a lot of trickery and deception can be used to claim what the horizon is and where it should be. It just so happens that when we look directly ahead like this, then a horizon is created in the center of our field of view. When we are looking at eye level like this, the surface will appear to meet the sky in the center of our field of view. Of course, if we change our line of sight, then we change where the horizon is, because it ultimately is a fixed surface. But as far as we can tell, it is a level surface, not a curved surface. So there is no bulge rising up in front of us, and we do not look down a bulge. This is obvious from the observations we make if we study what we see. There is only the assumption that we rise up in the air and look down a curve. But we're going to have a look now at what the different effects of perspective are and how we can translate that from a two-dimensional view like this into a side-on view. But first, I think it's important to address this issue: the difference between observations, measurements, and calculations. They are all involved in determining aspects of our physical environment, but they are also very separate and distinct. So an observation, of course, is something like this photograph. Yeah, it's an observation, and it's bulging. How about we put, there we go, that's more like it. That was just to show you what it would look like if we were looking into some kind of bulge. We just never ever see it like that. So what we see is this, and this is what flat surfaces do in our vision, whether they are short or long. If you put yourself above a flat surface, it will appear to stretch as far as your eye level if you're looking directly ahead. Of course, if you tilt your head up, then that horizon will remain fixed in its place where it was when you were looking directly ahead, and then you are free to look around. It's not going to follow you up as you tilt. So tilting doesn't affect where the horizon is. It just so happens to rise up or appear to rise up to our eye level because of perspective. So just to, this is an observation. So the entire globe model has been made with observations of the sky, which is basically a clock. We measure the time by the wandering stars, the sun and the moon, the seasons, and these all help us tell the time on the Earth. And of course, we have a very linear, often, view of time, but it's really just a flow. It's not something that can really be divided up into specific segments unless you want to find a way of measuring it. So this is the difference between an observation and measurement, is that in order to discuss or formulate models, you need to establish some kind of measurement. And then you can make calculations based on those measurements. But observations themselves are not really measurements. We can't physically measure the distance to the horizon here. This is not something we can measure. Of course, if we believe we're on a spherical Earth, then of course horizons are very, very important for that model, in order to say that we observe a horizon and we can make measurements and calculations based on a spherical model, and say and make predictions about the height or distance of something from that sphere, the angle at which they would have to look down, etc. That can be very precise, and we could interpret these things into the observations we make. But that has to assume a lot. We have to assume the Earth is moving and not the things above us. We have to assume that we're a sphere, yet we see no evidence of that. There are many things we have to assume in order to adhere to any particular model. So observations are not measurements. We can use them as a guide. We've got a rough idea just from the visual clues about how far we can see and what we are seeing around us, okay? But we can't actually measure these distances just by looking like this. There is no way. It's ridiculous to use just one image. I can't use this image to say that the Earth is flat or say that the Earth is round or spherical. You can't just use one image like this and make judgments from it. You cannot measure. Okay, so this is why they have to be combined. The observations have to be combined with measurements. But then what happens is you have calculations made from those measurements that can create entirely different models. And I believe that the globe is just it's an inversion. It's a complete, it's inside out to what we see, these observations that we make. And so we have to be able to reverse engineer all the ideas and interpretations that come with the observations that we've been told to associate with the globe. You have to be able to detach from all of those compartmentalized explanations and just make observations and compare them to the things we can know as being something that happens and we observe to be true in our local experience, such as something going off into the distance and appearing to sink towards the horizon. Yeah, this is something that we can observe and know is a true aspect of perspective. So, of course, we have a two-dimensional image here of a forward-facing view that needs to be translated into a side-on view or an orthographic view to give us more clarity about what we are actually seeing and how we see it. So let's have a look at how we can convert or translate the observer's view into a side-on orthographic view, incorporating perspective and things like angular size. So give me a while I try and go through this. What I suppose is worth showing is something like this. I've got here 7 lines, I think 1, 2, 3, 4, 5, 6, 7. Okay, and they're equally spaced down from the horizon. But what we actually see in each of those gaps becomes increasingly greater and more. We see across more and more distance within these gaps in our field of view, until we get very close to the horizon, then all of a sudden we are seeing across several miles of surface, whereas down here at the bottom of the field of view we're just looking at a few meters of whatever we can see in this particular segment, and it grows increasingly exponentially, maybe in the same way that we think about the globe Earth mathematics, 8 inches per mile squared. But the numbers are kind of irrelevant, because what we're talking about is a vector that can be scaled in any way, and it always involves degrees of circles. So these are things that can be divided up in many ways, and of course triangles also have angles that add up to 180 degrees. So everything can be divided up in this way, for example, where we can just take note of the fact that the higher up this goes towards our horizon in this two-dimensional view, the further and further we are seeing across that surface. And the same goes for any other kind of aspect you want to look at. So coming down, we have a few leaves in this block here, and we see more and more clouds across greater and greater distance as we come down. So the same thing as above, so below. The same thing is happening on either side of our horizon or eye level in this case because we are looking straight ahead. And the same across here. We have a gap here which features entire hills, but as it gets closer to us, it's just a few buildings. So it's all relative to where things are, and of course we are very familiar with our surroundings, so we can watch an aircraft go across this landscape and get a good idea about how far away it is, because we know about the way aircraft fly, and if it was close it would come across the screen very fast, and if the further away it is, the longer it takes to cross one of these gaps here. So again, but what we have is we've established some form of measurement. Again, it doesn't matter what numbers are actually applied to this. It's just that we've created these equal spaces and segments of a view that really doesn't have these divisions within it, but we then are attempting to measure it, so we have to divide it up into some way. But this is, the fact that it's a square is because it's a photograph, but we don't see squares and we don't see things as circles. You can't say what shape it is that we actually see things. So it's very organic, it's flow, and so this is why measurements are very different to observations. We make an observation, we make a judgment about distance and our location in it and how we're going to get somewhere and move about within our environment. We can do that with our understanding of perspective and depth of field that we have in our own eyes. But when it comes to interpreting that so that we can communicate what's going on in someone else's eyes, we have to then establish some kind of measuring format. But it doesn't, the actual numbers used are not important. It's more about ratios that are scalable, and of course they are, and this is why perspective has been manipulated into the idea that we're on a globe, and that is not necessarily the only way you can interpret it. You can interpret what we see in many, many different ways. So if I add some circles here, this might give us more of an idea of how our vision is working, a bit like a tunnel. If you can imagine these concentric circles, as they get smaller, they're representing places that are further and further off into the distance as they get closer to the center of our field of view in this horizontal view here. So again, we've got the same thing where the spaces between these circles are the same on this image, but the ground or the surface that they cover as they get closer and closer to the center becomes greater and greater. Okay, so you can take away the lines if you like, and just have this circular thing going on. So this tunnel of perspective that we might see. So that's another way of looking at it. If you want to, we also have, just going to find, we can also do this. We can also split it up into these lines of perspective. Again, these are arbitrary. They don't necessarily follow any particular angle, but we can then, we can split up what we see into these segments and then play around with the numbers, and we'll always be playing around with numbers that are similar to the angles that you get in circles. Not necessarily the measurements, but it's more about the angles. And of course, they all eventually add up to 180, 360 degrees. But again, this is just a way that we have chosen to divide up circles. If you just look at a circle, it is not anything that is definitive of being measured. It's only when we apply our own ideas about splitting it up into equal parts that we then form these measurements for a circle. As I mentioned here, that observations and measurements are very different things, but we can try to marry them together to arrive at some conclusions. And then, of course, we create these calculations, which can turn out to be anything. But let's have a look at how we can translate this kind of thing with let me just put the yellow lines back in again. Okay, so we've got all these different ways we can divvy up what we see, and we can apply this to create other perspectives of what we're seeing. So what I've done here is got the numbers 1 down to 7 to represent each of these lines. So this line here at the top of our field of view, going down here. So obviously, as I said, these represent further and further away points from us. So the number 1 being the closest one to us, number 2 another step away, number 3, 4, 5. But again, as I said, each one is equal in this representation, the gap between them, but they represent more and more space. They show more and more space in those gaps as they get closer and closer to the horizon. So these are all the different ways we could divide up the view and see what we can make of it. So if we go to this yellow line here is okay. This is a side-on view of this view here. Okay, so we have these numbers 1, 2, 3, 4, 5, 6, 7. As I said, each line is getting exponentially further away. I've not used any specific mathematical formula to get this, but basically kind of doubled or quadrupled the distance as we've gone along, or squared the distance. So we get these close ones here, and they get further. The gap gets further and further away, representing the small amount of surface that we see here around the edges, and the increasing surface or sky that we see in the same space as you get closer and closer to the horizon. So yeah, that's what we're talking about here, this difference between observation and measurement. Go back to that. Yeah, so we're translating this into a side-on view, and they get further and further away. So we can, of course, add... oh, no, not that one. Sorry. We may as well go with that then. Of course, most of the time we are on the surface of the Earth, but we've got to take that away and remember that our eye level and our perspective expands in both directions, up and down. It's just usually that the surface is in the way. So let's just put these lines here. So this just obviously represents the angles or the direction of a line of sight you might take apart from level here to get to one of these points. So you can see that 1 and 2 here, yeah, are close. There isn't much difference between the angles to them. And then we come down here and here, and we go past something that would be maybe like 45 degrees. And so then we can see that as we cross a greater and greater distance in this orthographic view, in these equal segments, we know that the further away something is, the more dramatic any change will be, even with any slight tilt. Yeah, so if you're aiming at some point up here, then you got quite a lot of leeway, but the closer you get to pointing at something very, very far away, the slightest difference in the angle that you're looking at it will make a huge difference to the center of your field of view and what that is actually ending up pointing at. It could make hundreds of meters, thousands of meters of difference just by shifting up or down or left or right a millimeter or so. So of course, when you have these angles here which become increasingly minuscule as you get closer and closer to the observer's horizon. So the further away something is, the less the difference in the angles, but the greater difference that they make if you just move very slightly. Here we can move quite a bit between 1 and 2 and 3, and everything will stay pretty much in that segment. But the further away we get, the more fine or refined we have to make any measurements of angles and predictions about where the line of sight actually is. Of course, it's interesting to consider that something in the sky above us along, say, this line of sight that goes to number 5, it could be anywhere in the sky. A sun or a moon or a star could be here or here or here or here. We would have no way to know for sure where it actually is along our line of sight. Of course, we can make models and anywhere and put the sun or the moon or a star anywhere we like along here and say, okay, that's its position, that's where it is according to observations. But this, again, is something that's very arbitrary. So these things have to be confirmed in other ways if you want to make measurements based on a single observation. It's virtually impossible to do. So hopefully that just shows that the view that we have in a side-on view of the observer's perspective is very different to this here, but we have to find a way of translating this view into a side-on view. Regardless of the shape of the earth that we think we're on, we have to understand these aspects of perspective and understand that it's easy to create models and calculations of observations that haven't been properly measured. So, if we can't make the physical measurement, then the observation doesn't tell us too much about the distance or the size, but we can extrapolate any kind of model we like by making calculations rather than measurements of our observations. So again, this is why we have to be really, really clear about the difference between making an observation, a measurement, and a calculation. So there you go. These are some of the understandings I have about perspective and what we're actually seeing. And obviously welcome discussion about that, but it has to be with the understanding that we are looking to explore beyond what we already know is the mainstream narrative and hasn't been proven in any scientific way. But hopefully if people can see what we see, then we can all get a better understanding of what we are actually seeing and where we are, who we are, why we're here, and all that jazz. That's the mission. And anyone who wants to drag their feet is welcome to do so elsewhere. Trolls and monkeys on spinning balls won't be fed. I want to make progress and explore the infinite possibilities that are ahead of us. Thank you very much.